and thanks for tuning in. Today, we're going to continue with How I View the Universe, Part 2. I want to take a moment to step back a little bit. I've been keeping a document with some of my thoughts in it. I've been having a couple Facebook conversations, that sort of thing. And so I thought I'd go back and share some of the thought process that led me to the current way I think about the way cosmology and space-time and quantum physics and mechanics works, to give you a better grasp on the way I think about it. Alright, so we're going to go back about 2 years here, when I first started writing down the thoughts I was having, and kind of a stream of consciousness. I'll interject some things, and by the end of this, you'll have roughly the same reasoning as I do. Again, I don't claim to be an expert, I do not claim to be authoritative, I'm just showing you how I arrived at the thought process I have, and if you find it useful, or you think there's something you can formalize, or perhaps it opens up a new avenue of thought for you, then even better. Again, this is not going to be highly technical with lots of math or anything, because I honestly don't understand all the math. But, yeah, let's jump right back into it. So going back to about September of 2015, I wrote, so I was thinking some more, and I think that perhaps I can make a further hypothesis, basically concerning those spins. So, what I was talking about here was the, up, down, top, bottom, charm and strange that you have on your quarks. Things like that. The spins of the electrons and stuff. Remembering that they exist in different directions in time. And what I mean to say there is, when you think of the spin that a quark has, and I'm using the term quark loosely here, you want to think of it spinning in time, not in space. That doesn't make sense yet, but hopefully by the end of this it will. So just keep that in the back of your head. Basically, furthering that, I think that somehow all fundamental particles are waveform functions. Again, some of the terms are not going to be exactly what you think they mean, because I don't have good ways to describe this yet. So in the same way that electrons are probabilistic representations of energy levels, and so on, quark triplets exist in these same sort of energy levels within, the subatomic particles. So if I'm breaking that down just a little bit, what you want to imagine, at least what I imagine, is that, for example, electrons have energy levels. Pretend for a moment that the other basic fundamental particles also have energy levels in time. The quarks and the protons and neutrons, they exist in such a way that, the valence ones are determined. And what we're talking about here is valence quarks. Again, just to throw that out there. And of course we know that there can be 3 or maybe 5 or maybe more valence quarks. And this is a fun thing, because if you remember, the quarks are a net charge of 0 within your proton, neutron, electron, so on. And again, I realize I'm mutilating some of this. That's not the point. But what that means is, there doesn't necessarily have to be just 3 of them. As long as their levels all equal 0 on the total, remember they're also always in flux because they're virtual particles. There could literally be all of them in the universe within 1 proton at any given point, but there could also be as few as 3 or 0, also in the same little bit of space for a different portion of time. But again, I'm getting ahead of myself. So perhaps it is there are typically 3 valence levels present in the subatomic particle. So what I'm getting at here is you have one that is a positive 2/3 and you have 2 that are negative 2/3 on their spin, let's say. And again, I'm just pulling the numbers out of my ass here. Those equal 0 the same as if you had 5 of the 2/3 and 10 of the negative thirds. And it doesn't really matter because they take up time, not space. Again, I'm trying to drill this in there. You're not thinking of this in space or energy terms, so to speak. You're thinking of it in time. But we'll come back to this at a later point. So, let's also go one step further. All 4 main forces are comprised of the spins as I described them previously. Again, we'll come back to it. I'm just laying the groundwork stream of consciousness right now. Bear with me. So quarks, again, using my definition as all fundamental particles rather than just what we call quarks currently, they spin through time, and it's useful to think of this topologically. I want you to imagine when I say they spin, they have 3 axes, and these give you the 2 different directions they can spin along each. So if you want to imagine it kind of like a donut, imagine that it spins through time like a wheel. It can also spin like a coin, but it can also spin like you're turning a rubber band inside out constantly, one direction or the other. And the net of these 3 forces in time, again, remember time is kind of different from space, but they're requisite of either, so that you get the 3 sets of 2 types of spins as they spin through time. And again, this will become important later. I'm just laying the groundwork now. You're going to have lots of questions. Put them in the comments, and we'll try to get through them. And for this example, imagine, and again, this is arbitrary, so just imagine with me. The first spin, kind of like a wheel rolling. Let's pretend that's forward and backward through time. And let's pretend that tells you that it's an up or a down spin. Now let's also imagine that as it flips like a coin, then you've got the second spin, which is maybe the top and bottom spin. Again, it doesn't really matter what you call these so much, but it's useful for communicating it to one another. And the third spin, spinning it kind of like turning a rubber band inside out, might be your strange or your charm, depending on which of the 2 directions you turn it. And each of those sets refers to 3 different directions in time. This will become more important as we talk about objects with mass and how the forces align and affect each other. I also have a basic understanding in my head I wish to communicate to you about how all 4 forces are a composite of this. But anyway, back to some more of the reading. And again, just keep this in the back of your head. We're talking about this in relation to time, not so much to space. The 2 are kind of like inverse functions, time and space. And time is kind of like a manifold between energy and space. But you could also say energy is a manifold between time and space. And that would also be more psychologically useful in other contexts. But again, this is not perfect. This is just kind of the way I visualize it to make the whole process make more sense to me. And I'm going to take the last few minutes here to respond to some comments from the last one. Neil Gupta asks, "What do you mean by the density of time?" Fair enough, I hadn't got to that yet because actually I hadn't even gotten to the density idea until like a year after I even started writing this stuff down, maybe a year and a half. So it is going to take us a minute to get there, but hopefully this has clarified some of that. Gravity does not take more time to happen than electromagnetism. This is correct. The difference is, when things are denser, as far as time is concerned, they simply have to move through more stuff to interact. This is why gravity, for example, tends to hold the planets in the orbits and acts over a very long distance, like from the center of the galaxy to its outer arms. Whereas electromagnetism tends to have a very much smaller radius, because it kinda needs a certain threshold of density of the particles to act, so to speak. But the denser those particles are, the more of them they have to go through. Yes, it moves at the same speed as far as time is concerned, although thinking of the speed of time is very strange. And we'll get to that. Again, this is going to be a long series. Do feel free to ask questions, and I don't care if I'm wrong, I'm just telling you how I think. Gravitational waves travel at the speed of light. Correct. Light also travels at the speed of light. But when I say the density of time affects it, think of like the event horizon on a black hole, or think of the redshift. You know, the speed of light is still constant, and photons never violate it. But relatively speaking, some particles do move faster than the speed of light away from other particles, and once you rectify for time, it's all consistent, and that's where this comes in. But again, we'll get to that, so on and so on. He says also, And when you say photons go all directions in time, what do you mean? Well, time is kind of like space. It occupies, or has rather, multiple dimensions, kind of like length, width, and height. But in time, it's strange to think about if you think about time the same way you think about space. But no, time, as he says, there are 2 directions in time. Well, no, there's more. But again, we'll get to that all in due time. Unless you're saying that time has more than 1 dimension, basically yes. I'm saying it has at least 3, which match the spins of the quarks, or the leptons or electrons, photons, whatever. From a photon's perspective, due to relativity, the slice of time in which it exists has been compressed in time so that the entire thing takes 0 time. Kinda. The net time it takes is 0, but it still takes time in every direction, even if the net is 0 when we observe it. But again, I think I might be getting ahead of myself here. And the photon doesn't travel through time at all. Well, that's correct. You've got to think of it not as a physical thing. It's not a point. It's like a wave, as far as time is concerned. And then he says I don't see how that equates to going all directions in time, which is fair. I haven't described it very well yet, so I can accept that. And that's where I'm going to leave it for today. Next time I may address the other comments which were left. However, I don't want to keep you here all day. That's why we're breaking it into parts into the first place. So if you enjoyed that, click the thumbs up and be sure to share it. Or if you're on VidMe, click the upvote. Go ahead and subscribe or follow me so you can see the next one when it comes out. Again, if you don't care for my other content, feel free to ignore it. You're not going to hurt my feelings. And I want to thank you all very much for tuning in. This is a lot of fun. I enjoy making these videos, and I'm glad some of you enjoy listening to them and watching them. And as always, this has been Reverend JR, signing off.